All right, hello everybody. We are doing flashcard 6, which is on the unit circle, what point sits at angle theta? The terminal side, or the ending side of angle theta meets the unit circle at the point whose x-coordinate is cosine theta and whose y-coordinate is sine theta. So we have that labeled here on the right. And the unit circle is a circle of radius 1. Okay, so starting from the origin, radius 1. And every point on it is literally cosine and sine of the angle, like you see here, cosine theta and sine theta. Okay, so looking down at our formula, we have x and y. This would equal the same thing as cosine theta and sine theta, with r equaling 1. So let's do a few examples. At 90 degrees, the points would be 0 and 1, or cosine 90 would equal 0, and sine 90 would equal 1. At 180 degrees, the points would be -1 and 0, or cosine 180 would equal -1, and sine 180 would equal 0. Okay? And then at 45 degrees, it would be square root 2 over 2 and square root 2 over 2. Okay? And that would be cosine 45, same as sine 45, which would equal square root 2 over 2. Are we good with this? Great. Okay, so a memory tip for you, alphabetical order matches x before y, which is cosine before sine, cosine before sine. Okay, and the background that we get from this is the unit circle is what frees sine and cosine from triangles. Okay, so any real number, positive or negative, large or small, gets a point on the circle. And who gave this to us? Euler. Euler completed this view in the 1700s, turning trigonometry into the study of functions. All right, so once again, let's define sine theta, cosine theta, and tangent theta using x, y, and r. Okay, so for any point x and y on the terminal side, the ending side at distance r from the origin, the three main ratios are what is defined below. So sine, cosine, and tangent are just ratios of the sides of the triangle. Okay, so then we draw the points from y over r, or x over r, y over x. So instead of just the SOHCAHTOA where you are doing like this, okay, you're using x, y, and r. Okay, so you can remember it like this. Okay, now you need to remember that your cosine is x and that your sine is y. Okay? Okay, so then let's try a couple examples. So for point 3 and 4, we want to use the Pythagorean theorem. Okay, so then we'll put 9 plus 16 here. And what does that equal? So then sine theta equals 4 over 5. Okay, you see where I got that? Okay, and then cosine theta equals 3 over 5. And tangent theta equals 4 over 3. So if you look back here, you can understand where I got those terms from. Okay, so then let's try this again for -5 and 12. Okay, r equals 13. So sine theta equals 12 over 13. And cosine theta equals -5 over 13. And tangent theta equals -12 over 5. Okay, are we good with this? Okay. Now, if 0.1 and -1, that means r equals square root of 2. Okay, so that means my sine theta would equal negative square root 2 over 2. And my cosine theta equals negative 2 over 2, square root 2 over 2, square root 2 over 2, and tangent theta equals negative 1. Okay? All right. Remember that r is just a distance, so it's always positive, okay, because it's the distance from the origin, okay, and the x and the y are the ones that carry the signs. So the background comes from, you guys recognize this, the Pythagorean theorem, okay, Pythagorean theorem. It doesn't really fit, so I'll put it on top. These definitions extend the, like I said earlier, SOHCAHTOA to every quadrant, okay? Because x and y can be negative while r stays positive. All right, so flashcard 8 of the unit circle, what is a reference angle? Find it for 210. All right, so then a reference angle, the acute angle, for reference angles, the acute angle between the terminal side and the x-axis, okay? So you swing your ray, and then it's that gap, okay? That always positive gap from your ray to the x-axis. It tells you the size, and the quadrant tells you the sign, okay? So let's take a look. The formula that you can remember, always from the x-axis, remember that, okay? So quadrant 2 is 180 degrees to the theta, and then from quadrant 3, it's the theta minus 180 degrees, and for quadrant 4, it's 360 degrees minus the theta, okay? So for 210, that is in quadrant 1, quadrant 2, quadrant 3, and this is quadrant 4. Okay, so 210 is in quadrant 3, and the reference angle would be 210 minus 180 degrees equals 30 degrees. Okay, are we good with that? Cool. So it's just taking this and then finding the difference to that. Okay, this 180, this 360. All right, 135 degrees. So in quadrant 2, okay, in quadrant 2, the reference angle equals 180 minus 135 degrees equals 45 degrees. All right, we good with this? Great. Now how about 300? Okay, 300 degrees. That lies in quadrant 4. Okay, that lies in quadrant 4. And so then I would take 360 degrees minus 300 degrees, and that would give me 60 degrees. Okay, so the graphing tip is if the reference angle is always, the reference angle is always the acute gap to the x-axis, never to the y-axis. Okay, so reference angles are a compression trick. So one small table of first quadrant values covers the entire circle, okay? So just another way for you to remember this so that when you have to do this on your own and you're solving questions, you're not always trying to look for your reference guide, but you know it at the top of your head, okay? So then find the reference angle for the size of the value, and then you can use all students take calculus to attach the correct sign, okay? Is it positive or is it negative? Okay? Okay, for slide number 9, flashcard number 9, in which quadrants are sine, cosine, and tangent positive? And the little trick to remember this is all students take calculus. All students take calculus. Now, if you take a look at this chart, and this is something that usually professors and teachers will use just to help you remember it off the top of your head, again, without you looking at a reference guide, okay? So all students take calculus, all positive in quadrant 1, and then sine is positive in quadrant 2, and then tangent is positive in quadrant 3, and then cosine is positive in quadrant 4, okay? All right, so then let's take a look at our formula here. Quadrant 1, all of them are positive. Quadrant 2, only sine is positive. In quadrant 3, tangent is positive, and in quadrant 4, cosine is positive. And just a couple examples here. So sine in quadrant 2, positive, okay? And so you have sine 150 is greater than 0. And cosine in quadrant 3 is negative, okay? And because in quadrant 3, only tangent is positive. So cosine 210 is less than 0, okay? And then tangent in quadrant 4 is negative, okay, because only cosine is positive. So let's say tangent 300 degrees is less than 0, okay? Memorize this, please. All students take calculus, and then you're marching counterclockwise from quadrant 1, okay? It's just something to help you remember, okay? And then let's look at the bottom here, some background. So there's nothing really to memorize blindly here, okay? On the unit circle, cosine theta is the x coordinate, and the sine theta is the y coordinate. So the signs simply follow the signs of x and y in each quadrant, okay? And the tangent is their own quotient. Are we good with this? Okay, so for slide 10, flashcard 10, we have special values here. So what are the exact values for sine 30 degrees, sine 45, and sine 60? Okay, so let's take a look at sine of the special angles. So the three values climb a simple ladder or pattern of square roots over 2. Okay, so the sine values climb like square root 0 over 2, square root 1 over 2, square root 2 over 2, square root 3 over 2, square root 4 over 2, 4, 0, 30, 45, 60, and 90 degrees. Okay, so then 30 degrees would be over here. Okay, what do you have? 1 over 2. And then sine 45 degrees, just on that ladder again, stepping up. Okay, and sine 60, square root 3 over 2. Okay, and this also equals 1 over 2. So let's do a couple of examples again. Just 30 degrees, sine 30 degrees equals square root 1 over 2, or 1 over 2. And sine 45 degrees equals square root 2 over 2, and sine 60 degrees equals square root 3 over 2. And just something to help you as a memory ladder, you can write square root 1 over 2, square root 2 over 2, square root 3 over 2 in order, okay, because the sine climbs as the angle grows, as you can see it here, okay, on this side. All right, now these are not decimals, just to memorize, but the lengths read off the two special right triangles, okay, if you guys haven't noticed that. And exact values matter because they keep later algebra clean, okay, especially in identities and calculus, okay, and some of our students have already experienced this. All right, so flashcard 11, special values, give the exact values of cosine 30, cosine 45, and cosine 60. So the cosine of the special angles, it runs a similar ladder, just, okay, it's the reverse. Okay, so then cosine is the same ladder as sine, but it's walked backwards. So you start high and then you come down, all right? So then cosine 30 then equals square root 3 over 2, and cosine 45 equals square root 2 over 2, and cosine 60 would be 1 over 2. Okay, so just once again, cosine 30 degrees equals square root 3 over 2, cosine 40 degrees equals square root 2 over 2, cosine 60 degrees equals 1 over 2. Again, it's just the sine ladder backwards, okay? Same, cosine is the same ladder descending. The two functions trade values at complementary angles. Remember that cosine is the complementary of sine, okay? So the reversal is no accident. It's cosine theta equals sine 90 degrees minus theta, okay? So the reversal is no accident. It's cosine theta equals sine 90 degrees minus theta. So cosine at 30 degrees must equal sine at 60 degrees. Okay, so if you can spot that symmetry, okay, symmetry halves when you need to remember it. Card number 12, give exact values for tangent 30 and tangent 45 and tangent 60. Okay, so tangent of the special angles, we're going to divide each sine value by the matching cosine value, okay, y over x. So tangent is just sine divided by cosine, okay, sine over cosine. So to divide the two ladders and we can get its value. So tan 30 is square root 3 over 3, tan 45 equals 1, and tan 60 equals square root of 3. Okay, and let's work that out just in case someone got lost there. So sine 30 over cosine 30 equals 1 over 2, okay, over square root 3 over 2, and that equals 1 over square root 3 equals square root 3 over 3. Okay, and let's try tangent 45, which is just square root 2 over 2 over square root 2 over 2, and that gives us 1. Okay, and then again, sine over cosine, so we have square root 3 over 2 over 1 over 2, and that gives us square root 3. Okay, so you can just divide the letters since tan is sine over cosine. Okay, and then tan 45 again just equals 1, which gives us that middle. Okay, that solid middle. So tan 45 equals 1 because 45 degrees, that line rises exactly as fast as it runs. So the tangent is literally the slope, okay, of the terminal side. And the rationalized form, okay, square root 3 over 3 is just the conventional way, okay, conventional way to write 1 over square root 3, okay. Flashcard 13, right triangles, state SOHCAHTOA for a right triangle. SOHCAHTOA, what does that stand for? In a right triangle, each trigonometry ratio compares two sides, and it's relative to the chosen acute angle. So SOHCAHTOA, let's just do that again. That's sine equals opposite over hypotenuse, and cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. Okay, so we can write that down again, opposite over hypotenuse, and adjacent over hypotenuse, and opposite over adjacent. Okay, then our labels are here. Adjacent means that it's just touching this angle, hypotenuse always the longest, and across from our 90-degree angle, and our opposite across from the angle that we want. Okay, so if opposite is 3, hypotenuse is 5, then sine theta would be 3 over 5. Okay, let's try another one. Adjacent 4 and hypotenuse 4. Okay, that's ka. So that would give us 4 over 5. And TOA, okay, opposite 3 and adjacent 4, that would give us 3 over 4. Okay, so that's just for memory. You can say SOHCAHTOA as one word and label the hypotenuse and the opposite and your adjacents. Okay, so opposite is opposite the angle, and hypotenuse is opposite the right angle. Okay, and trigonometry began here because Hipparchus built the first chord table. A chord is just a straight line joining 2 points on a circle. Okay, and around 150 BC, before Christ or before Common Era, to do astronomy. Okay, and the word trigonometry literally means triangle measurement. And the unit circle definitions you learned later contain these as special case r equals hypotenuse. Flashcard 14, what are the side ratios of a 45, 45, 90 triangle? Okay, so the 45, 45, 90 triangle, the two legs are equal and the hypotenuse is square root 2 times a leg. Okay, so again, in a 45, 45, 90 triangle, the two legs are equal, okay, and the hypotenuse is a leg times square root 2. A square cut, basically, in half, okay, a square that is cut in half. So then our formula would be 1, 1, and square root 2. Legs are 1, and the hypotenuse would be 1 times square root 2, okay, which gives us square root 2. And legs 5 and 5 would give us a hypotenuse of 5 times square root 2. And hypotenuse 8, each leg would be equaling 4 square root 2. Okay, are we good with this? Okay, so we want to remember that 2 equal angles, 2 equal legs, and then the square root of 2 always belongs to the hypotenuse. Okay? Okay, so if you cut a square along its diagonal, and this triangle appears, okay, that's the Pythagorean theorem, okay, and it gives the diagonal 1 squared plus 2 squared equals 2. So then the hypotenuse is square root 2. And it is the source of every 45-degree trig value, so you need to remember this, okay? All right, so flashcard 15, right triangles. What are the side ratios of a 30, 60, 90 triangle? The 30, 60, 90 triangle, the short leg opposite 30 degrees is half the hypotenuse, okay? So the long leg is square root 3 times the short leg, all right? And the short leg, again, is opposite 30 degrees. So here, short leg, opposite 30 degrees, okay? And so we have 1 square root 3, 2, and the short leg opposite 30 degrees. Let's try it out. Short leg 1 and long leg equals square root 3, and the hypotenuse equals 2. Okay? And short leg 4 equals long leg 4 times square root 3, and the hypotenuse would give us 8. Hypotenuse 10 would give us a short leg of 5, okay? And then long leg equals 5 times square root of 3. Did we get that? Okay, so it's going to take a little bit of practice, okay? So smallest side faces the smallest angle. Again, 1 faces 30 degrees. Square root 3 faces 60, okay? And then 2 faces your 90-degree angle, okay? So if you slice an equilateral triangle in half, and this triangle appears, the base halves to 1, and the sides stay as 2. Okay, and the height, or the altitude, comes out to square root 3 by Pythagoras. It supplies every 30-degree and 60-degree trig value. Okay?